Ever get that feeling like you're working on a puzzle and then realize the box is way bigger than you thought? That's kind of where we're headed today.
Oh, yeah. I know exactly what you mean.
We're talking multiverse and how it smashes right into this huge question. Do we actually have free will?
Definitely a big one.
And we're not just talking about one angle here.
Yeah.
We've got cosmology, then there's quantum mechanics, which is always a wild ride. And of course, we got to bring in some deep philosophical thinking too.
It's a fascinating mix, and what makes it so compelling is how it forces us to rethink, well, almost everything. Our basic assumptions about reality, about our place in the universe.
Are we just along for the ride?
Exactly. It really makes you question cause and effect, the idea of possibilities, even what it means to be you.
Okay, so let's map out where we're going with this. First up, we got to tackle what it actually means if there are infinite universes out there. Right. Then there's this head scratcher. We've got randomness happening at the quantum level, but at the same time, the universe seems to follow these predictable laws. How does that even work?
Yeah, it's a real puzzle.
Oh, and we can't forget the science behind all of this. We'll be looking at things like cosmic inflation, the universe going through a growth spurt, and this thing called the inflaton.
The inflaton is key.
So we'll definitely unpack that. Now, obviously, with all this talk about a multiverse, we have to wrestle with the big question. Does free will even exist if the universe is deterministic? Or even if it's all just probability playing out?
That's the million-dollar question, right? And the sources we have really push us to think critically about what it means to make a choice in that context.
And hold on tight, because things are about to get even weirder. We're also going to dive into something called the measure problem. Imagine trying to figure out probabilities when you're dealing with infinity.
It's a real mind bender.
Right. It's like, if you have endless possibilities, how can you even say how likely any one of them is?
Exactly. One of the sources compared it to predicting which raindrop will fall next in a never-ending storm.
Okay, that's a great visual. And this whole infinity thing has led to some, let's say, creative solutions like the Immortal Watcher. We'll explain what that is later.
It's definitely out there.
But we'll also look at a more grounded approach, the idea of the causal diamond.
Much more down to earth.
And here's the coolest part. This isn't just theoretical stuff. The sources actually talk about real physics experiments happening right now, trying to find evidence for this mind-blowing cosmic stuff.
Oh, absolutely. Experiments that are looking back billions of years, trying to find proof of inflation.
Which would then make this whole multiverse thing even more likely.
It's all connected.
So we're talking about massive telescopes peering into the depths of space, basically trying to rewind the universe's story. And at the heart of it all, we keep bumping into this philosophical question. If the cosmos or multiverse is ruled by laws and quantum randomness, are we truly calling the shots?
It makes you wonder, doesn't it? Is free will just an illusion?
Right. One of the sources even paints this picture of a library with infinite books, each book representing a different universe.
I love that image.
Me too. And then it asks, what are the chances of finding a specific book, a specific story? That's the measure problem. And then there's that even bigger question. Do we, as characters in one of those books, have any say in how the story unfolds?
That's free will in a nutshell, right?
Exactly. So our mission today is to unpack these incredible ideas, break down the most mind-blowing parts for you, and hopefully leave you with a slightly clearer view of this incredibly complex topic.
And maybe a few more questions, too.
For sure. Okay, let's start with this whole multiverse idea. Like, what does it even mean to talk about an infinite number of universes?
It's mind-blowing, right? But the sources present this not just as a sci-fi fantasy, but as a possible consequence of what we already understand about cosmology.
So it's based on real science.
Yeah. You see, if cosmic inflation, this incredibly rapid expansion of the universe, right after the Big Bang actually happened, and there's growing evidence that it did,
Okay, so let's say it did. What then?
well, then the conditions that set off our Big Bang could have happened and might still be happening countless times in other parts of space-time.
So like a Big Bang factory constantly churning out universes.
In a way, yes.
Wow. Okay, and the sources keep bringing up this inflaton field. What exactly is that, and why is it so crucial to this whole multiverse theory?
Right. Think of the inflaton field as the engine behind this initial hyper-expansion of the universe. It's a theoretical quantum field that, in its early state, had a massive amount of energy.
Okay, tons of energy. Got it.
And that energy caused space-time to stretch and grow at an insane speed, exponentially fast. But here's the thing. This inflaton field wouldn't necessarily decay uniformly everywhere,
Okay, what do you mean?
like lose its energy. So some regions might stop inflating, creating universes like ours, while others could keep inflating forever, possibly birthing new bubble universes all the time.
So picture bubbles forming in boiling water, but instead of steam, we get entire universes popping up. That's pretty intense. But, okay, let's say there are infinite universes, each with its own laws of physics, its own history. How can we even think about probability in that context? It seems like anything goes.
That's the heart of the measure problem. When you're dealing with infinity, the usual rules of probability just don't work.
Because usually, we're working with a limited set of options.
Yeah, exactly. But with an infinite number of possibilities, how do you assign a probability to any single event? It becomes really tricky.
Yeah, the math just breaks down. One of the sources put it like this. What are the odds of picking out a specific atom in an infinite universe? It's not zero, but it's also not a normal number.
It defies our usual way of thinking about probability.
So how do physicists and philosophers try to wrap their heads around this problem?
Well, there are a few different approaches. One that pops up is the immortal watcher idea.
Okay, mortal watcher.
Yeah.
Sounds intense.
It is. Imagine an observer who exists outside of every universe and can somehow see and count everything that happens across the entire infinite multiverse.
Wait, so they can see into all these different universes?
That's the idea. And by counting how often different things happen, they could then try to define probabilities based on these infinite tallies.
But as the sources point out, that seems more like a philosophical thought experiment than actual science. Like, what even is this immortal watcher? How can something observe infinite universes?
You're hitting on the core problem. It raises more questions than it answers about the nature of reality and what it means to observe something.
Exactly. And that's where the causal diamond comes in, right? This idea felt a bit more manageable.
Definitely more grounded. The causal diamond focuses on what a single observer can actually see and interact with in their own universe.
So their own little corner of reality.
Yeah, basically. It's the finite region of space-time where this observer can both send and receive signals throughout their entire lifetime.
So we're not trying to deal with a whole infinite multiverse anymore, just what this one observer can experience.
Exactly. And by limiting ourselves to this finite diamond, we can actually start making meaningful predictions about probabilities within that observer's reach. It shifts from these big philosophical ideas about infinity to something that's potentially testable.
Okay, that makes more sense from a scientific standpoint. Instead of trying to catalog an infinite library, we're focusing on the books that a single reader can actually reach during their lifetime.
A perfect analogy. And this brings us to how these theories connect to actual experiments that are happening now.
Right. These aren't just abstract ideas, they have real-world implications.
Exactly. Scientists are looking for evidence that could support these theories, like these projects trying to measure the B-mode polarization of the cosmic microwave background radiation.
I'll be honest, that sounds super complicated.
It is. But the basic idea is that this B-mode polarization is a specific pattern in the oldest light in the universe, the leftover glow from the Big Bang.
So like ancient light from the very beginning of everything.
Yes. Think of them as tiny ripples in space-time left over from the universe's explosive birth. These ripples are primordial gravitational waves, and their existence is a major prediction of cosmic inflation theory.
So if we find these ripples, it would be like finding proof that inflation happened.
Exactly. It would be like finding inflation's fingerprint.
And if inflation happened, the chances of a multiverse become much higher.
Exactly. So these incredibly sensitive measurements are really trying to answer fundamental questions about the origin and nature of reality itself.
Wow, okay, so we've explored the multiverse and how probability gets really weird when you throw infinity into the mix. Now let's shift gears to the other big piece of our puzzle, free will. Our sources do a great job of highlighting the tension between, that feeling we have of making our own choices.
Right, like we're in control.
And the implications of a universe that might be ruled by fixed laws, or even just randomness at the quantum level.
It's a deep philosophical problem, because if the universe operates according to set laws of physics, like classical physics suggests, then every event, including our decisions, could be seen as already predetermined.
Like a chain of events set in motion from the very beginning.
Exactly. And in that deterministic view, it becomes really hard to reconcile the idea of true free will, of genuinely choosing between different options.
Like everything's on a set track.
Right. But one of the sources uses this helpful analogy. Imagine driving from one city to another, and you know there will be traffic at a certain spot.
Okay, so you know it's coming.
Yeah. Now, even though the traffic is predictable, your decisions leading up to that point, taking that particular route, leaving at a specific time, they still felt like your choices in the moment.
Right, you still made those decisions.
Exactly.
Yeah.
So the sources argue that even in a deterministic system, our experience of making choices can still be meaningful. Our decisions might be part of a long cause and effect chain, but that doesn't necessarily mean we're not making them.
It's like our internal thought process, the weighing of options, still feels real, even if the outcome was kind of inevitable.
Yeah, the subjective experience still matters.
Okay, but then we have quantum mechanics throwing a wrench into everything.
Quantum mechanics always shakes things up.
Because at its most basic level, there's this inherent uncertainty and randomness. Like the famous Schrödinger's cat thought experiment, that poor cat. But how does this quantum randomness relate to free will? Does it somehow open up space for genuine choice?
It's an interesting question, but here's the thing. While quantum mechanics brings in unpredictability at the level of individual particles, that randomness isn't the same as free will.
Okay, so just because something's unpredictable doesn't mean someone's making a conscious choice.
Right. Randomness doesn't equal a conscious decision. A good example is radioactive decay. An atom decaying is a random event, but it's not a decision made by the atom.
So even with all this randomness, there are still rules governing how things unfold.
Exactly. The sources point out that while individual quantum events might be random, the overall behavior of a quantum system is still guided by deterministic equations. We can calculate the probabilities of different outcomes, even if we can't know for sure what will happen in a single instance.
Got it. And then there's the many worlds interpretation, which some of the sources mention. This idea gets pretty wild.
Oh yeah, many worlds is a big one.
It basically says that every time a quantum measurement happens, the universe doesn't collapse into one outcome, but rather splits into a bunch of parallel universes, each representing a different possible result.
So every possible choice you could make is actually happening in some other universe.
Mind blown. So a multiverse created not just by inflation, but also by every single quantum decision point.
Exactly. It's like a branching tree of realities with every possible path being taken.
But does that solve the problem of free will, or just make things even more complicated?
It's a good question. Even in a many-world scenario, within each specific branch of reality, our actions might still be determined by the chain of quantum events that led to that particular universe.
So even though every possibility is playing out somewhere, our own individual experience might still feel predetermined.
It's possible.
So whether we're looking at a multiverse born from inflation or from quantum events, this question of whether our choices are truly free remains a huge mystery. The sources really emphasize how much we still don't know.
It's a debate that's been going on for centuries, and it doesn't seem to have an easy answer.
Exactly. And what's even more thought-provoking is this idea that free will might be something that goes beyond our current scientific understanding. Is it possible that consciousness has some inherent ability to make genuine choices that physics can't fully explain?
That's a possibility the sources raise, and it's a really intriguing one.
Or maybe, as some of the material suggests, free will is an emergent property, something that arises from the complexity of our brains and our interactions with the universe, but is ultimately still governed by physical laws that we haven't fully grasped yet.
That's another interesting angle. Maybe our feeling of freedom is real, but its origins are much more complex than we currently understand.
So the sources leave us with this idea that our understanding of both choice and the nature of reality itself might be incomplete. Perhaps we need a whole new way of thinking to truly reconcile free will with the universe, whether it's one universe or a multiverse.
A scientific and philosophical breakthrough.
Right. Okay, so let's recap. We started by diving into the mind-blowing concept of the multiverse, this possible collection of infinite universes born from cosmic inflation. We talked about how that leads to the measure problem, the challenge of defining probability when dealing with endless possibilities. And we explored the various attempts to solve that problem, from the abstract immortal watcher to the more scientific causal diamond.
And we can't forget about those real-world experiments that are actually trying to find evidence of inflation.
Oh, absolutely. Those experiments are trying to glimpse the universe's earliest moments, which could give us huge clues about whether a multiverse really exists. Then, we tackled the enduring mystery of free will, looking at how it might fit or not fit within deterministic or probabilistic views of the universe, including the wild implications of quantum mechanics.
And the key question we kept coming back to is whether free will can truly exist in a universe or multiverse that seems to be governed by fixed laws or quantum randomness. The sources suggest that even in a deterministic scenario, our experience of making choices might still be meaningful. But at the same time, they emphasize that just because something is random doesn't automatically mean it's a result of conscious, freely willed action.
Right. Quantum randomness in itself isn't the same as free will.
Exactly.
So we're left with this fundamental question that the sources pose. Is free will something built into consciousness itself? Something that goes beyond the laws of physics as we currently understand them? Or is it a product of the incredible complexity of our brains and the universe? Something that emerges from processes we haven't fully figured out yet.
It's a question worth pondering.
Definitely. We hope this deep dive has given you some new insights into this fascinating intersection of cosmology, quantum mechanics, and philosophy. And more than that, we hope it sparked your curiosity to explore these questions even further on your own.
Because the more we question, the more we learn.
Couldn't have said it better myself. Thanks for joining us on this wild ride through the cosmos and the mysteries of our own minds. Until next time, keep exploring, keep questioning, and keep that sense of wonder alive.